Howdy folks. So the reason I made this video is because I thought maybe some people might want to understand why in implicit differentiation, when we do the derivative of something like, y to the third power, okay, if we do the derivative of this with respect to x, d dx, why does it wind up being, okay, so we do 3y squared, and then why is there the dy dx part kind of tacked on there, okay? And so I want to go through why that happens. And first I want to apologize to my A2 class because I was trying to explain this and I got sort of carried away and a little frustrated, but I wasn't really frustrated at you guys. I was actually more frustrated at myself. So I'm sorry that I got frustrated the way that I did. But here is, I'm just going to do a quick explanation using the chain rule why that dy dx is on there. So let's say we have, I'm going to go back to the example we did in class, which is x squared plus y squared equals 1, which is the relationship for a circle, for the unit circle in particular. And what I showed you in class is that if we want to identify dy dx, that we're going to find the derivative d dx of x squared. Then we're going to d dx, find the derivative with respect to x of y squared. Then we're going to find d dx, the derivative of x, or the derivative with respect to x of 1. Now, the derivative of x squared, we've been doing stuff like that for several weeks now. And the derivative by the power rule here is going to be 2x, then plus. Now, what I had taught you is that the derivative of y squared with respect to x, I said what you do is you apply the power rule to the term itself, so it's 2y, and then kind of throw on a dy dx, and then the derivative of a constant is 0. Okay, and then I said you have to solve for dy dx. So we would move the dx over or the 2x over minus 2x, cancel, and now we have 2y dy dx equals negative 2x. And then I said we want to get dy dx by itself, so we're going to divide by 2y. That's going to cancel the 2y, divide by 2y. And over here it's going to cancel the 2's. And all we have left now, dy dx, is equal to negative x over y, which is the rate of change in this relation right here. Okay, so we would need both an x and a y value to identify a slope, especially in this case because for almost every x, there are 2 y values. So we would need to pick which y value we wanted and put it in here. So now I want to explain why in the world do we put on that dy dx when we do the derivative of the y squared portion. Okay? Well, really it's a chain rule thing. I'm going to get rid of this, and I'm going to get rid of this, and I'm just going to focus on the y squared. Okay? Let's get rid of that. I'm just going to focus on the y squared part. If I want to find d dx of y squared, okay? d dx of y squared. We can think about this using the chain rule, okay? We can think of y as it's not an x obviously, but we can consider it some sort of function, okay? And so when we do chain rule problems, so for example, if we had like x cubed minus 11 to the 4th power, the way we do the chain rule is we do the derivative of the inside and the derivative of the outside. I'm going to do the derivative of the outside first. So I'm going to ignore what's on the inside here, and I'm just going to take my 4, and I'm going to apply the power rule. The 4 is going to go in front, so 4 times 1 is 4 times, then the inside, we're not going to change the inside at all, and then we're going to reduce the power by 1, so it's 3. So we got 4 times x cubed minus 11 quantity to the 3rd power, and then we multiply that by the derivative of the inside with respect to x. So d dx of x cubed minus 11 is equal to 3x squared. So when we do the derivative of the inside, we're just going to multiply by 3x squared. And by the chain rule, that is now the derivative of this composition function. Okay, so if you can understand that, then this shouldn't be a problem for you. What we're going to do is we're going to look at y squared like it's a composition function. We're going to think of it as y in parentheses squared. And so when we do the derivative of the outside first, we're going to take the 2 and multiply. We're going to apply the power rule. 2 times, there's a 1 here. 2 times 1 is 2. Then we're going to leave the inside unchanged and then reduce the power by 1. So 2 minus 1 is 1. So now we just have 2y. This is the part of the chain rule where we just do the derivative of the outside. And now we're going to multiply by the derivative of the inside. So we are going to do d dx of the inside function. Well, what is the inside function? The inside function is just y. Okay? And what is d dx of y? Well, for a long time we've been saying that if you want to find the derivative of y, this is just equal to dy dx. Okay? Now I've already said, if you're not sure about that, I've already said in the past that if you want d dx of f of x, I have told you that you can write that as d f of x dx. I've said that. Okay? And I have said that you can also, like, what if it was a case where you had y equals x to the third power? And I said, what's the derivative? If I say d dx of x cubed, okay, that's the same thing as saying d dx of y, because x cubed and y are the same thing. And then we would write d dx of x cubed is 3x squared, and d dx of y is dy dx. In other words, we would say that if y equals x cubed, then dy dx is equal to 3x squared. And the way that happens is we take d dx of y and d dx of x cubed, oh, I should have done the bracket around the x cubed, d dx of x cubed, and we get dy dx is equal to 3x squared. So the whole idea, whenever you do d dx of y, you get dy dx. Similarly, d dx of the letter A would be dA dx. d dt of the letter R would be dr dt. Okay? It's basically just, it's like you're multiplying, x over 4 times 9 would be 9x over 4. You multiply this times what's in the numerator. Okay? So d dx of y is simply dy dx. So when we do the derivative of the inside, the derivative of the inside, y, is dy dx. And so when we do the chain rule, we do the derivative of the outside times the derivative of the inside, which is dy dx. And that's where that dy dx comes from. So when we do implicit differentiation on something like this, let's say x to the third minus y squared plus 4y to the fifth equals, equals 9. Say we have this relation, and we're going to do implicit differentiation. When I do the derivative of this term, that's easy, 3x squared, minus the derivative of this term is 2y, that's the derivative of the outside, times the derivative of the inside, dy dx, plus 4y to the fifth, well, we're going to do the derivative of the outside, 5 times 4, 20, leave the inside alone, reduce that to 4, 20y to the fourth power, times the derivative of the inside, which is dy dx, equals the derivative of a constant is 0. And now we want to solve for dy dx. So we would subtract 3x squared from both sides. Subtract 3x squared. That's going to cancel here. Simultaneously, I want to factor out a dy dx. I'm going to divide this by dy dx and divide this by dy dx and put the dy dx on the outside. Dy dx. Okay, cancel. All we have left is negative 2y. Cancel. All we have left is 20y to the fourth. So I got 20y to the fourth. I'm just switching these around because I like having the minus afterwards. Minus 2y equals negative 3x squared. And now to solve for dy dx, we divide by 20y to the fourth minus 2y. Divide by 20y to the fourth minus 2y. This cancels, and now dy dx is equal to negative 3x squared over 20y to the fourth minus 2y. And there's your implicit differentiation. Okay? I hope that helped, and let me know if you have any questions.